In previous tutorials, we talked about the limited number of IPv4 addresses. Creating subnets is one way that we can efficiently use the limited addresses available. In this tutorial, we'll look at taking a single address range and creating several smaller networks from it. Before we start, we'll start with a few definitions. You may hear the terms Class A, Class B, or Class C networks. We don't tend to use those terms as much anymore, but they have been used for a number of years. A Class A network has a mask where we have 255 in the first octets and zeros in the other. So these are local addresses, and we have a number here in the IP range which goes from 0 to 127. That's referred to as a Class A address. And if you had a network, for instance, 10.0.0.0, it would be assumed that the mask for this would be just 255.0.0.0. Class B, so here you had actually up to 1 million hosts that you could have here. So these were reserved for very large organizations, so they could request a Class A address. Class B was a smaller number of hosts that we could have. We could have about 65,000 hosts in these networks. The first network number started with 128 to 191, and it used a network mask like that. So if you had an address which was 130.16.2.5, you would say, that's a Class B address, and you might guess that the mask was, as we see above here. Class C was reserved for smaller networks. We have only 8 bits for host, and so we can have up to 255 host addresses, which would give us 253 hosts that we could have. 3 octets were used for the network number. So the network mask was 3 255s and a 0. Now that was in what we call classful addressing. Today, that's not an efficient way to hand out IP addresses, and we use something called classless addressing, where we take any network address range that we're given, and we can subnet it or break it up into smaller networks. For instance, if you're given a Class A network, you could actually break this up into thousands of smaller networks, which may all host just about 100 machines. So learning to subnet addresses is very important. So we're going to go over that in the next example. So here we're given an address /24, and if we look at all the network bits here with this /24 shows that we have this network mask. We have an organization though, we're only given this one address range, and what we have is we have 4 sections in our organization. Maybe we have marketing and engineering, sales, financial. And for security, we want to make 4 separate networks. And maybe we only have 20 machines in each network. We want some room to grow. How can we create 4 networks with this one network range? Well, the answer is in looking at the host bits and seeing that we don't need all these host bits to be host bits. Maybe we can borrow a few to set up smaller networks. And so what we're going to do is we're going to borrow enough bits to give us 4 sections. Well, how many bits do we need? Well, in binary, if we count to 4, we go 0, 1, 1, 0, 1, 1. And we see that we need 2 binary bits to number 4 sections. So what we're going to do is we're going to make a division here. And we're going to use these bits as, some would call it the subnet bits, but really these are going to become part of the network. And so now in the mask, these are going to be set to a 1. So our mask is going to change here from a 0 in this digit to having 2 1s here. Well, 2 1s with all zeros means that this number here, 1 1 with all zeros, is 192. So this is going to become our new mask. These 2 bits here are going to be the bits that we're going to manipulate to give us our 4 networks. So how does that work? Well, for the very first network, these 2 bits here are going to be 0, 0. And the rest of the bits are going to be used for our host definition. So if we look at the address of the network, we would have 190, this number here, dot 33, dot 45. These 2 bits are a 0 for our first network, and the network address has all the host bits as 0, so this is going to be a 0. What's a broadcast address? Well, broadcast address, we said, was when all these host bits here are 1. So we have our network bits, and we have all 1s. We have 6 more 1s here for our host bits. So this is the broadcast address, and 0, 0 with 6 1s. Let's see, this is 63. So our broadcast address is 190.33.45.63. Now that means any of these numbers in between here, that is from 1 to 62, can be assigned for hosts. Often one of them are allocated for the gateway. Now we could choose the gateway address to be anything, but as an example, we could say, okay, for our gateway, we're going to use .62. That is 1 down from the broadcast address. So that means that all the devices in my network from .1 to .61 I could use for devices. That's the very first network. Now, these 2 bits I can change. I have control over them. And so for the next network, I'll change them to a 0, 1 pattern. So we'll get rid of some of this. So now if I change these bits to 0, 1 for the network part, I again look at, well, what's my network address? So this is network number 1. This is network number 2. So the network address will, again, it will have 190.33.45. These don't change. Dot, I have 0, 1, and I have 6 zeros here for my network address. Network addresses always have all the host bits as 0. So this is the number 64. The broadcast address for this network has these all 1s. And so 0, 1 with all 1s, this number here is 127. So my broadcast address is 127. All these are the same. Again, I could choose a gateway for any number in between, so from 65 to 126. For the purpose of our course, we'll always choose one less than the broadcast. That's just sort of a local standard, so we'll just choose this. And then any other in between here from 65 to 125 can be used for hosts. So we continue on that with these 2 bits, changing them next for network number 3 to a 1, 0, and then finally to a 1, 1. And what we would get, oops, you can go through that as an exercise. And what we get here is this for our 4 networks. So what we've done here is we've taken a single address range where we have been allocated 255 machines. We don't need 255 machines in one network, but we do need 4 networks, maybe with 10 or 20 in. And we've subnetted. We've borrowed 2 of the host bits to subnet this into 4 networks. How many hosts can be in each network? Well, we have not 8, but 6 bits. We have, remember a formula, 2 to the n, 2 to the 6 is actually 64 numbers or addresses I have in each network, but one of them is reserved for the network itself, with all the host bits as 0. One is reserved for the broadcast. So I have 62 devices that I can have in my network. One of those is usually a gateway device. So let's see how you do on another example. So for this example, like the other tutorials, you can just pause it. Basically, you are given this address and you have to create, as efficiently as possible, networks that can create up to 300 devices per network. What I want you to do is assign the IP address for just the first 2 of those networks. Pause now and then we'll continue for the answer. Now we said we wanted to be as efficient as possible, so I don't want to take up more host bits than would be for 300 devices. So what you'll notice here is that this is /16. So my mask is 255.0.0. So I have 8 bits here and 8 bits here. I have 16 bits that I can borrow bits from. How many bits do I need to handle 300 devices? Well, remember that 2 to the 8, if I have 8 bits, I get 256 addresses. That's not enough for what I want. 2 to the 9 is going to be double that, or 512. So I need 9 bits, 9 host bits. So I need all the host bits here, because my host bits start from the right-hand side, and I need 1 of the bits in this octet to be used for hosts, and the rest can be used for addresses. So if I were to just look at 150.35, and I'll write the rest out in binary here. We have 1, 2, 3, 8, and we have another 8 for my last octet. And what we said is we're going to split here, and we're going to use these on this side to be part of the network. And these here are all going to be host bits. Now I've borrowed 1, 2, 3, 4, 5, 6, 7 bits. That's a lot. That's 128. So I could have 128 networks here, but I'm just going to assign the IP addresses for the first 2. So I take all these bits I'm borrowing and I look at the very first 2 addresses in a counting sequence. That is, these are all zeros. The next in the sequence are going to be when this bit is a 1. So these are going to be the two networks. So let's look at network number 1. Network number 1 is going to have all these bits as 0 right here. So my network address is going to be just 0 because the network address has the host bits all 0. So that's a network address. What's the broadcast? The broadcast has, pick another color, has all the host bits, and remember this is a host bit here, has all these host bits a 1. Well, my network bits are all 0. My host bit here is a 1, so this octet here becomes a 1. And this is all 1, so this becomes 255. So my broadcast address is 150.35.1.255. I could choose a gateway in here. Typical gateway choice might be .1.254. Devices in this network would be assigned 150.35.0.1 to 255, and then I could change this number to 1, and it would go from .0 to 253. 254 assigned for the gateway. Network number 2 would have this bit right here would be a 1. And so if this bit was a 1, with all the host bits as 0, the network address would be 150.35. Now, this is a 1, this is a 0, 1 and 0 is 2, so I have .2. These are all 0, so 2.0. And we can also see in a counting sequence that this went from 0.0 to 1.255. We would see that the next address in logical sequence is 2.0. So this makes sense for network number 2. The broadcast address has this a 1, also has this a 1, so in this octet I have 1, 1, which is a 3. All these bits are a 1, which is .255. And a gateway could be assigned any of these numbers in between, but for convention we'll just follow the one less than the broadcast, and it would be 254. So that would be an example of breaking this address up to creating the very first two networks, each of which could handle at least 300 devices.